Alrighty, guys, we'll continue on talking about proving triangles similar. And today, we're going to look at three different theorems, talk about what they mean, and then we're going to use them in practice to prove that two triangles are similar. Okay? So the first one is the angle similarity postulate. And um, later in practice, when we start proving like why we know they're similar, we can just use these abbreviations that I've given you. So angle similarity, you just abbreviate double A with a squiggle. All right. So the theorem says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, so the bare minimum you need to prove similarity is just two angles congruent. So if you have two angles marked, or you can find two angles being congruent, then you can say they're the triangles are similar. So notice here in this picture I've given you, we can say that angle A is congruent to angle D. That's because they both have one little arc. And then angle B is congruent to angle E. So then we can say, because we've satisfied angle, we say triangle. Remember now, I can pick the order on the first one. So I'm going to say A, B, C is similar to triangle. Now because I went A, B, C, I have to keep that same order. So I'm going to go D, E, F. How do we know that? Because we used angle similarity. Okay. Next theorem is side angle side similarity. Oops, sorry. Let's get that up a little bit. So we say if an angle of one triangle is congruent to an angle of a second triangle, and the sides including the two angles. Now that means that the angle is between the two sides. Okay, that's just all that means. If those sides are proportional, then the triangles are similar. Okay. So notice that we have two angles marked 50. So we say angle B is congruent to angle F. Okay. Now we need to match sides up appropriately. So notice that 12 and 8 are the smaller of the two, and 24 and 16 are the bigger. So I'm going to match those up. So I could say AB over DF equals 12 over 8. Now you don't have to do this part with the letters. I'm just doing it on this instance to show you where it's coming from. Now 12 over 8 will reduce, and I want you to reduce it. So 3 halves. Now we check the other side. BC over FE, and that will be 24 over 16. That reduces also to conveniently 3 halves. So notice that we have our two pairs of corresponding sides, or one pair. Yeah, sorry, I got tongue tied. Our two pairs of corresponding sides are proportional, meaning that I can set up the proportions and they'll reduce to the same fraction. That's what proportional means. So we've satisfied side, angle, side, and so we can write our similarity statement. Now I'm going to write this as A, B, C is similar to triangle. Now because I went A, B, C, watch that order. A, I go down the smaller side to B, across the bigger side to C, and then back up nothing. I have to follow that same order on the small triangle. So A, B, C, that order on the small triangle would actually be DFE. So DFE. So notice I went down the small side, up the bigger side, and then down the nothing side. So make sure you pay attention to the order on your statements here. And this is by side angle side similarity. All right. Next one. So this is side similarity. Oops, can't see it. Okay. So this says if the corresponding sides of two triangles are proportional, then the triangles are similar. All right. So this time we have to check all three pairs of sides because we're trying to use side similarity. Okay. So essentially, when you have side, you should have all three sides given to you, and then you match them up. So I like to go from the smallest to small, medium, and large. So 10 is the smallest here, and 20 is the smallest here. So AB over EF. 10 over 20, which reduces to 1/2. Okay, that's the small ones. Now we have to check the medium ones. And remember, I have to get this 1/2 every time, or I should if it's similar. So let's check our medium sides. So that's going to be BC over FD. So that's 15 over 25. And if you reduce that, you get 3/5. Okay. Now, I didn't realize this when I made this note page, so I kind of apologize for this. But I also like it because it shows what happens when you don't have all proportions, or they're all proportional. These end fractions here should have matched, okay? Because they don't match, these aren't similar, okay? But let's check the third pair and see what happens. So we're going to look at CA over ED. And that will be 21 over 35, which reduces to 3/5. So those two match, those didn't. All three have to match. So in this instance, this example is not similar. However, if they all three did match, then we would say we used this side similarity to say that the triangles are similar. All right, I'm just gonna get up a little bit. Okay, now we're going to try and use one theorem for each problem to see if it works. State if the triangles are similar. If so, state how you know they're similar, and then write a similarity statement for those that are similar. Okay? So sometimes what will happen with these things is the triangles will overlap. Okay? And they'll overlap and one triangle might be flipped. So you have to be careful when you're setting up your proportions. Okay? So first, I try and see if I can build an acronym. So remember, our acronyms are AA, SAS, or SSS. Okay, so I see two pairs of sides already. So I know it's going to be either this one or this one that I need to use. And so I'm thinking, do I know anything about that other pair of sides? Can I use some sort of mathematical trick to get there? And the answer is no. You can't use this one on this specific problem because you don't know anything about the other side. And so because the other two sides are there, they want us to use this one. So we're going to try and use side angle side similarity to get there. Okay? So what we need to do is we need to match up sides and we need to find us an angle. Well, Mr. T, there's no angle marked. Where am I going to get that angle? Remember, sometimes there's angles that are congruent in disguise. They're trying to make you remember that. So notice right here in the middle, I have a kind of an X-ish shape. If you remember back when you did geometry part A, and you talked about something called vertical angles, which angles that are across from each other in this X shape are congruent. So we know that that angle and that angle are congruent because they're vertical. Okay? That's going to pop up sometimes, and you've got to remember that. If you see this X shape, go ahead and mark the congruent arcs on your angles. Go ahead and put it. It may not help you, but it's probably good practice just to put it. All right, we have our A. Now we need our two S's. And so I want to match up sides. So I noticed that in the smaller triangle, 40 is the smallest. In the bigger one, 64 is the smallest. So those are going to go together. And if you reduce that, you're going to get 5/8. Now we'll check the other side. So 65 over 104, because those are the two larger ones. And if you reduce that, hey, you get 5/8 again. So we have done the S, both S's, and so we know this worked. See, I kind of checked that off for myself. Okay, now I need to write my statement. So triangle symbol. I'm going to start here with this smaller triangle, and I can write this in any order I want. So I just picked the order U, V, D. Okay, you honestly could have picked any order you want. It doesn't matter. But whatever you write here, you have to follow for the second triangle. And because I went from U to V to D, notice I went from nothing to the small up the medium. I have to keep that order. So nothing, small, big. So the second triangle I have to write as F. Whoops, I messed it up. As F, E, D. And we said this was by side angle side similarity. Okay, so on a test or a quiz, if this is off, like the letters are out of order, I'm going to count off for it. You have to make sure the order is correct, okay? All right, same thing. Notice that you have all three sides marked for you. That's your clue that they're wanting you to try and use this theorem that we did up here. It didn't work, okay? They want you to check all three pairs of sides. And so that's what we'll do. So looking in the small triangle, 10 is the smallest. Looking in the big one, 35 is the smallest. That means those go together. And if you reduce that, you get 2/7. Move to the medium. So 16 over 56. That reduces to 2/7. Looks like it's going to work, but remember we have to check all three. So let's check the big ones. 18 over 63. And would you look at that? All three match. So we know we use this. All three worked. All right, so triangle. Now I'm going to start with the small one, and I just picked the order C, D, E. I went alphabetical on that one. Okay, now look at that order. C, D, E. I went down the medium side, the small side, the big side. So I went medium, small, big. I have to keep that over here. Medium, small, big. So R, S, T. And this was by Whoops, not side angle side, sorry. Side, side, side similarity. All right. We will move on. A couple more. All right, same directions. We have to determine if they're similar. And look at this problem. Notice that you're only given an angle marked. And if you could sit and stare at this for 10 minutes and there's no way you could figure out any method to find any side links. So that is if you can't figure out any sides, that's probably your clue that they want you to use angle. Okay? And they've given you one angle pair, so go ahead and mark that off. See right here, R and E. But how am I going to get the other angle? Well, remember, there's an X shape right here. And I told you, anytime you see the X, go ahead and mark vertical angles across from each other as congruent. Now we have our other angle pair. And so we know these are similar. Now let's write a statement. I'll write it down here. Triangle, I started with the top one. I said SRQ, so let's do that. SRQ is similar triangle. Now, look at how I wrote that. I went SRQ, so I went from nothing marked to the 2 arcs to the 1 arc in that order. I have to keep that. So that would end up being DEQ. And we said this was by the angle similarity. All right, let's check one more. So notice that you have an angle marked and 2 pairs of sides. So they're prompting you to try and check for side angle side similarity. Okay, and we know we have the angle marked. Okay, it's between 2 pairs of sides, so that's now we have to use that. Let's check our sides. So in this triangle, 12 is smaller, and in this bigger triangle, 53 is smaller. So we'll set those two together. And that's not going to reduce because 53 is prime, nothing goes in there, so it's done. Let's check the other pair. That's 21 over 91. Uh-oh, this reduces. It reduces to 3/13. These aren't matching. If this worked, we had to have those matching. And so because it's not, we can say these are not similar. All right. Now these next 4 are examples of what we kind of did yesterday. You've kind of already done this part of it. We're going to find the missing side using the proportion stuff. So on this problem, it's kind of hard to tell, but I want you to notice that when I first set this up, I did it wrong and got a weird answer. You shouldn't get any weirdish answers on these, I don't think. But I had to sit and stare at it for a moment, and I noticed that between the 18 and the question mark, this question mark side looked a little bit longer. And so I thought that it matched up with the 10. And so that's how I matched it up. I'm going to say that X goes with 10, which means that 18 goes with 9. So notice I'm going from the big to the small this time. Do my cross multiplication. X and 9 gives me 9x. 10 and 18 gives me 180. I'll divide the 9 out. So X is 20. Or question mark, whatever. All right. Now, same thing. So we got a smaller triangle overlap with a big triangle. 18 is the smaller one down here, and so I'm going to match that up with the smaller one, 42. And then x over 63. Do my cross multiplication. 42x equals 1,134. And divide 42. We get x to be 27. Okay, two more. Now, I like to include these kind of problems because they kind of freak kids out, but they're not that bad. So notice that it's two triangles in one. You've got this smaller triangle right here with the known sides of 44 and 24, and then you got this bigger triangle. So they're kind of sharing this angle right here at G, okay? But it's a similar idea. So notice that this small side 24 is paired up with this total length side of 66. So that's where I start. 66 over 24 equals x over 44. Cross multiply. 24x is 2,904. Divide. And we get x is 121. Okay. Now, how do we know that's right? What if you're just concerned that it's not right? What you could do is actually look at the proportion between the two. So, physically divide 66 by 24. You get 2.75. What is 121 divide 44? 2.75. Those decimals match, and so we've done this problem correctly. Now let's do another one. So notice you got all the sides of the small triangle known, and then one of the longer sides of the big triangle is not known. So you have some options. I'm just going to show you what I picked out. I noticed that 98 went with 84. And so that means that x must go with 72. The other option you could have had was 77 over 66 instead of this, but it should work out the same. Cross multiply. 84x equals 7,056. Divide 84. Divide 84. And you actually end up with x being 84. Now, don't freak out about that. I know this does not look like 84 when compared with this. The drawings aren't to scale, okay? It's just, I guess when they drew it, they didn't make it accurate, but... All right, that's it about proving triangles similar. All you need to know is these three theorems that we talked about, if I can find them. Right here. All you need are these three theorems: angle, angle, side, angle, side, 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 side. You just check the respective components. All right, your homework will be posted with the problems assigned. If you have questions, let me know.